Uh, Good morning to all, and thank you for being here this morning. As usual, a quick request to all of you: kindly keep your mic muted and switch off your video, except for Subbu and Sudhakar. Quick review of what happened last month. We had the bird race. Had a lot of Bonia, Umesh, Bhai. Everybody stood by, Sudhar, and basically to help out. We had 18 teams who had, there were 20 who had actually registered, but I think 18 final logbooks were uploaded from here onto our email ID, and from there, because Madhav picked it up from Georgia, Atlanta. And he looked through them, and in about 45 minutes to 1 hour or so, he came back with his observations, which was very nice. And I very happy that the red-throated flycatcher was what got the bird of the day. It was very interesting. We also, after a gap of 2 years, met physically and shared our experiences and had dinner together and all that. But the AWC is complete in all its respects, and we've covered about 29 sites, and all of them have been now uploaded onto eBird. And so the general observation has been, of course, whenever our members went, water levels were high, number of birds low. So this has been going on for the last couple of years. So I think that seems to be the trend, excepting that, you people who have been birders who have been going in between, starting the second, third week of December till last week. So there's somebody's mic on. There's somebody's mic on. I think somebody's calling out. So there have seen numbers and certain numbers which were there. And since most of our members are on eBird, I think there's a lot of data which has gone on to eBird, which may not be AWC linked, but otherwise during the season, a lot of data has gone. And one nice observation which Srinivasji and Umesh Bhai, I think during the last week, sometime when Srinivasji was free, they quickly went over to Muthukadu and they saw the curlew sandpiper, which I think is an excellent sighting. And they have been, these kind of single bird sightings. Of course, in the month of January, I thought I'll say it when I introduced Subbu. Subbu was in the papers for having seen the long-billed dovichr in Kanavandurai, which is the estuary where the Army River discharges itself into the Pulikat Lagoon. Anyway, so generally the season apparently still seems to be good. And on the 26th and 27th of this month, the Forest Department is going to do across Tamil Nadu synchronized count of birds in bird sanctuaries, national parks, reserve forest, and forest lands. So if any of you are interested to participate in it, kindly send me a mail. I'll then collate everything together, get in touch with the wildlife warden here in Chennai and the DFO Chennai, and see if we can help out 26 and 27. There were quite a few of our members who had helped out for the wetlands and the course, and if a few of you are really interested, it's on the 26th and 27th of this month. I'll be sending out more details as us. So that's it for now, and the annual field trip. 32 members are going to be traveling to Bench. This was a long, postponed, supposed to happen in April 2020, is now finally happening in May 2022. The person who's organizing, Shalik Jogwe, and all the other service providers were kind enough to, accommodate us, give us a credit note, etc., and say that okay, you can come late because of the pandemic. Very nice gesture, which has been acknowledged by us as well. And so, without much ado, I think we'll allow Subbu to make his presentation. Subramanian Sankar is not a stranger to us. He's been part of us for a very, very long time, a very, very keen birder. It's a great pleasure to actually bird with him, because on the field there is not just observations and done. I think he spends a lot of time observing the behavior of the bird, and it's not at all surprising that he's got into bioacoustics. I think that was something that was bound to happen. I do remember him telling me that a couple of years ago, in order to perfect the whole heart, he had spent more than a month at Cornell trying to understand how this entire process of bioacoustics works. And then now he's made it his full-time avocation, which is wonderful. So, Subbu, we are ready to hear you.
Thank you, Vijay.
I request everyone else other than Subbu to keep your mic muted, please.
Sorry, I had kept my mic on mute. Are you able to hear me? Hello?
Yes.
Yes, yeah. Good morning, everybody. This is actually a long-awaited session, and I'm sorry that I could not make it in the earlier instance. We have just modified a little bit. This is we have changed the title to listening, recording, and interpreting the bird calls. Although it's a very vast subject, I'm trying to make it as simple as possible. And sometimes, if I'm overstretching, kindly just don't mind. So this is a very important organ in the human body. This is the human ear. We have two on either side of the head at the space of about 5 to 6 centimeters. This helps us in listening to let us keep to the topic, bird calls. So this is the ear is only a tool. It is a brain that comprehends the sound. And we all hear a lot. We hear a lot of sounds around us. There are a lot of good sounds, bad sounds around us. But there is also something called as a listening. So we don't really pay very close attention to this process called as listening. And listening is a very important process as far as the bird calls, listening to the bird calls is concerned, because you can hear a lot of bird calls, but only if you listen very carefully, you will be able to focus on the bird's calls. So what is the difference between the hearing and listening? The hearing is a passive physical act. It has to do with the perception of sound. It does not rely on concentration. It's like collecting a lot of data. We hear sounds and words all the day long, even if we are not paying attention to them. What is listening? Listening is actively paying attention to the words and sounds that you hear and to absorb their meaning and develop an emotional response. Listening is a mental active process that requires multiple senses, and it's a voluntary act. You can always hear to sounds and words without having to listen or focus. So active listening. So see, when you're going in the field and listening to the bird calls, it requires a lot of curiosity, motivation, purpose, and effort. And it is attempts to understand what the sound is and trying to connect with the object object that is giving out the sound. That is, if you would like to pay close attention when you want to understand something and to solve a problem, and it is not inattentive, it is with full attention and concentration that you listen. So this is a very important component of what do you call listening to bird calls. So that is why I brought this concept up, because you always hear but listening doesn't happen always. So in the field, if you want to listen to the bird calls, so you have to focus and concentrate on the bird. So there may be 100 birds calling out, not 100 birds, but 15 birds calling around you. But it's always, if you pay attention, you can just isolate one call among the many calls that are heard in the background. So listening is a very important part of listening to bird calls. Now we are going to see a small video on how the hearing process works.
Have you ever wondered how sounds make their way from the source all the way to your brain? Take a trumpet, for instance. When it's played, it makes sound waves in the air. The outer ear catches the waves, which then travel through a narrow passageway called the ear canal. The sound waves reach the eardrum, which is a membrane roughly half the size of a dime. They make the eardrum vibrate, which in turn vibrates 3 tiny bones called the malleus, incus, and stapes. These bones amplify or increase the sound vibrations and send them to the cochlea. The cochlea is shaped like a snail and is the size of a garden pea. It is filled with fluid, and the sound vibrations make this fluid ripple, which creates waves. Hair-like structures called stereocilia sit on top of hair cells and are grouped together as hair cell bundles inside the cochlea. The hair cells inside the cochlea ride these waves, and the hair bundles are moved. The hair bundle on top of the hair cell turns these movements into electrical signals. As the hair bundles are moved, ions rush into the top of the hair cells, causing the release of chemicals at the bottom of the hair cells. The chemicals bind to the auditory nerve cells and create an electrical signal, which travels along the auditory nerve to the brain. Different hair cells respond to different frequencies of sound. The hair cells at the base of the cochlea detect higher-pitched sounds, such as a piccolo or flute. The hair cells toward the top of the spiral detect progressively lower-pitched sounds, such as a trumpet or trombone. At the very top or apex of the spiral, the hair cells detect the lowest-pitched sounds, such as a tuba. The auditory nerve carries the electrical signal to the brain, which interprets the messages as sounds that we recognize and understand.
So now you would have understood the physiological process of hearing, how the sound travels through the ear and reaches your brain. And hearing is a perception that has evolved very recently. See, there are other senses, as you can see. You can sense of smell, taste, touch, sight, and hearing. So the taste evolved 2 billion years ago, and then the sense of touch evolved, and about 570 million years ago, evolved the organisms evolved the sight and smell, and finally the hearing perception evolved about 275 million years ago. So we always pay more attention to the sight, to what we are seeing, the visual objects. Our sense of hearing actually is always placed secondary to our vision. The vision always dominates. So you always tend to, that is why there are so many photographers, so many people who actually captures the photos, videos, and we always crave for more visual imagery. Whereas the hearing, as it is evolved very late, I feel that like you are not having a so dominant, the hearing is not so dominant, and as a consequence, we are not paying much attention to the sounds unless we actually put some effort. There are certain organisms like the dogs and cats that have really acute hearing sense as compared to the human beings. Why? Because dogs have 18 muscles and they can detect up to 50,000 vibrations per second, 18 muscles each ear. So they can turn their ear and they can listen to the sounds and pick up sounds from very far away, and also they are all very sensitive. And as you can see, they can actually perceive about 50,000 vibrations per second, which is about 50,000 hertz. Cats have even more acute sense. They have 36 muscles per ear and that can detect up to 64,000 hertz, whereas humans have only 3 muscles and they can only hear about 20,000 hertz. So human hearing is not very great as compared to a cat or a dog. But there are other organisms in the animal kingdom which have more acute hearing than the human beings. I was very surprised to learn that moths have a very good hearing, and the Indian elephants, the barn owl, and the flying fox. So these have a very good hearing sense as compared to the human beings. But how did this hearing evolve? And I was also very curious to know how this hearing evolved. It seems, according to the evolutionary biologist, the hearing evolved along with the ability to chew the cud or the vegetable matter that the animals were eating. So the chewing and the hearing co-evolved. That's what the evolutionary biologists say. And according to the fossil studies, the middle ear was created from the jaw bones.
I'm on the MNS.
And the middle ear, as you already have seen and already know, that there are 3 bones: there are malleus, incus, and stapes. So the human hearing range is between 20 hertz to 20,000 hertz. Beyond this range, it is very difficult for us to hear. We cannot hear. And as you grow older, also your hearing, there is a hearing loss. But there are birds which call below 20 hertz, and there are birds which are called above 20,000 hertz. And for that, we have a lot of devices to pick up those calls and maybe convert them into the hearing range. And this is a very fascinating video. You can see this.
Meu nome é Juan Pablo Culasso e eu sou um gravadorista de sons da natureza. Eu localizo o som do pássaro primeiro com meus ouvidos para depois sim colocar o fone e ter uma noção de onde ele está para apontar o melhor possível o micro. Então, ele está mais ou menos nessa direção. E aqui nesta Mata Atlântica temos uma biodiversidade incrível. Eu sou cego desde nascença, porque geralmente o termo que se usa é pessoa com deficiência. Eu acho uma ridiculez. Eu, mais ou menos, faz 12 anos que me dedico a gravar os sons da natureza. Foi no Uruguai, quando eu tinha 16 anos por aí, o Dr. Santiago. Ele tirou o equipamento da mala, colocou nas minhas mãos, ele falou algo assim: esse aqui é um gravador, esse aqui é o botão de rec, esse aqui é o play, e agora vai gravar. Daí eu comecei a gravar. E parecia que estava fazendo isso fazia séculos. E a partir daí não parei mais. Aqui seria um bom lugar para gravar uma paisagem sonora, por exemplo. Eu tinha um grande problema com essas questões de cores e plumas. Eu tinha na minha cabeça que aves mais coloridas, com uma plumagem mais vistosa, elas cantavam harmoniosa, melódica, linda. Eu fui no Museu de História Natural. Eu comecei a tocar aquelas aves e me descreviam as cores. Minha visão mudou completamente. Com cores menos vistosas e com as penas menos chamativas, cantando muito bem. Chip, 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 chip. Sempre que eu venho gravar em algum lugar, e dependendo de como que é o lugar, eu trago meu cão-guia, que é a Rania. As Ranias são meus olhos, né? Que coisa mais bonita do que isso. Ela tem uma personalidade muito forte. Left. Hoje eu acho divertido, mas antes não. Antes era meio frustrante. Nesses lugares eu tento capturar a essência, né? E se eu vou para uma floresta tropical, eu quero gravar a chuva, uma trovoada. São sons que marcam, que realmente marcam aquele lugar. Então eu me sinto mais em paz quando a noite chega. O som que resume para mim a noite é a mãe da lua. É uma ave que tem um som extremamente característico, muito intenso, muito musical. Para a grande maioria das pessoas, os sons são invisíveis. Meu trabalho, minha missão é que eles se tornem visíveis. Feche os olhos e ouve um pouco. Se deixa transportar pelo som. Para mim, ouvir está dentro de cada pessoa. Só que é algo adormecido.
So the most fascinating thing about this guy is like he could not see the colors because he was born blind. But then he took a help from his friends and went to the museum, and he could feel the birds, and as they described, and he could connect the sounds to the birds and people describing the colors, and so he was able to get a sense of it. And this guy, I met him I think a couple of years ago, and he's a very fascinating blind person to recording calls, and he is one of my inspiration. Now I would request everybody to just close your eyes. If not, you cannot tie anything. Just close your eyes and just listen to this piece. This was recorded in Nanmangalam during the COVID lockdown, and you just listen to this for a few minutes and try to not use your visual sense to see the screen. And just close your eyes and just listen to this and try to experience it. This this is a 2.39 minutes clip, and how many bird calls were there? See, I could count about 13 to 14 bird species were calling, but the most important bird, the prominent bird, was the common iora, and there was all other birds in the background. And see, when you listen to the calls without your visual sense, then I think you are getting more data, more information, which we are missing out. See, we are seeing the bird, but we are unfortunately not listening very keenly, and then we are not getting the full information on the birds. So it, it becomes more important for us to improve our listening skill, um, so that we can get the complete information on the birds, not only its physical appearance but also its vocalizations. And it requires effort, and it is not so easy like you take a camera and click it and then process it. So the learning curve in recording bird calls is more, so the curve is more. It will take some time for you to actually master it. Okay, now we will just get into some physics of this whole thing. So how does the sound travel? It's actually a pressure wave that travels, and the call from the bird goes and reaches a human ear. So you can see, you would have studied in physics, and you know the waves have there's a distance between the waves, and you can see, as from the picture, there is one X line and the Y line. So you can see in the horizontal is a time line and the vertical is the amplitude. And you can see the point of high pressure and the point of low pressure. So the wave travels from the vocal cord of the bird and reaches the human ear. And there is a normal air pressure, a decreased air pressure, and there is an increased air pressure, as you can see from the diagram. Yeah, how does this is just the particulate wave, like you get the wave as a particles. It's showing how the particles travel in a wave form. Yeah, here you can see how the bird is calling when it is in a quieter sound, how the amplitude is less, and the louder sound, the amplitude is more, and also the lower pitch sound and the higher pitch sound. So you can see the higher pitch sound, the frequency is very less between two waves, whereas in lower pitch the gap is bigger. So the bird calls with its vocal cord, which is called larynx, syrinx, and it depends on the muscles of the birds in producing the sound. Okay, now we are going to see some common birds and their calls. These are very common birds. I am not picked up some very abstract, very rare birds. Most of the calls are recorded by me. Some calls are recorded by somebody else. I think this was recorded in Nanmangalam. See, we are not going to go into the name of the birds, basically because everybody is interested only in the names of the birds. First thing they will come to the field, say they will call out the names, and they will want to list it. But this process is not at all a good process, because people are not observing. Once they identify the bird and they get the name, they are immediately going to stop observing the bird further. So what I do basically is, when I take out kids to the field sessions, I never call out the names. I just allow them to see the birds for a while, and then make them write all the key points, features in a notebook, and then only I will, maybe I will not even tell the name. So therefore I have put only the Tamil names here, so kindly do not mind. So those who can read Tamil, you can see the name of the bird. So this is another common bird which is available everywhere in the city, urban. You can also listen to its call. See, these birds, even though they are common, they have many vocalizations which are we miss out. We are not listening. See, the house crow, the crow, for instance, which are very common, the mynas, they make like innumerable call variations are there. We do not know what they are, why they are making so much of variable calls. Maybe they are breeding. It's a territorial call. Scientists are still studying, so we do not know why, what for it's making those calls. But there are hundreds of different variation of the calls. So you keep on listening to it, you will find that they are vocalizing more and more, and you are also able to identify more patterns in their calls. So see, even though see some people may be saying why you are listening to these common birds, but common bird calls are the most understudied as far as I'm concerned. This is a very common bird in our gardens. It has many call variations. This is one of the calls that I recorded in our apartment around where I'm staying. Okay, now we talked about something about the listening, how to listen to the bird calls, how listening is more focused, more requires more effort, more concentration than hearing. We hear a lot of sounds around us, but in order to focus on a particular sound, how we have to pay some extra effort. And some common calls of birds that are around us. Now we will go into the next section, which is how to record the calls. Yeah, what for we are recording the calls? What is the purpose of recording the calls? See, so the question also applies to why we are taking photographs. The photograph is taken basically to identify, out of curiosity, to identify the bird. And I started by taking photos of the birds around me because I do not know the bird. So I took the photos, I put it on a computer, and then I checked with other people. I had a field guide. I then wanted to know what was the bird name, why is it called so, and all such things. But when it came to the question of the calls were new, completely new. It is like an alien language to us. So we don't know what the bird is calling for. And all of a sudden, when I started getting interested in these bird calls, then I wanted to listen to it again. Maybe try to identify the call and try to understand which bird is calling. So I started recording with my small dictaphone, Sony dictaphone. I started recording all these calls, and then I put it in a computer. And later this fascination grew up. Then I even switched over to a smartphone. The smartphone call recording happened. And then finally, then I wanted to graduate into a much more sophisticated system. So currently I'm using a latest technology in recording the calls. So the recording calls is used to gather more information on the bird. That is useful to make a complete picture of the bird. And it may not be useful to you, but it may be useful to some researchers also to make, because it's still an area where nobody understands fully what is going on. And if you put that into a database through a citizen science effort in a platform called eBird or something like that, so maybe some researchers will be actually looking into all the calls and then try to find some pattern or symmetry and try to understand. So it is a way of helping science. So this is why we are recording the calls. So how do you record calls? So there are various ways of doing it. So you have a smartphone. Nowadays everybody has got a smartphone, and there are a couple of apps which are recommended by the scientists who are studying this. So you go to the Google in an Android phone. There is a Rec4 is one of the very popular apps. And there are also something called as a shotgun microphone. You can see in the picture, and a parabolic microphone. These are all connected to a recorder, which you can see on the right bottom screen. And the recorder has got a memory card which will actually save all these sounds in a particular format, which is recommended. We will not go into it detail. So let's see what the Cornell lab. Yeah. So what they have done is they have actually done a review of all the gear. So as you can see, there are several recorders that they have recommended. So it depends on the price. So it depends on your budget also. You can buy a recorder which suits your purse, and not necessarily that you should go in for the high-end model. So there are sound devices and Tascam. These are all commonly available in the market. You can get it from Amazon, or if you have somebody residing abroad, you can ask them to get it for you. And you also have the microphones that connect to the recorder. So they have also reviewed the microphones. So there are various shotgun microphones are available, Sennheiser. So you can see this is available in the website. I can share the link with you. You can just go and have a look at it. So there are various kinds of microphones. We will not go into it, the technicality of the microphones. So just that we need some kind of an equipment to record the calls. So I'm just telling this because to give an idea, in case you're interested, tomorrow you can go and look at it and then start with your whatever suits you. Okay, this is a gear. This is in the Macaulay Library, Cornell Lab of Ornithology website. So you can go to the library, you can Google and find out. There you can find out all the details about the gear available. Okay. Now let's see how to record our audio.
Perhaps you've been recording with a smartphone or a handheld recorder for some time now, and you'd like to up your game. One of the best things you can do to improve the front end of your system is to attach a directional microphone. For wildlife recording, two types of directional mics are commonly used: the Parabolic Reflector system, or Parabola for short, and the shotgun microphone. In this session, we'll talk about the Parabolic Reflector. Specifically, we'll talk about four things: why use a parabolic reflector, how it functions, how to aim a parabolic reflector, and the pros and cons of using one. So let's get down to why you'd use a parabola. Any sound can be electronically amplified, but electronic amplification comes with a cost: noise, often described as hiss. As one increases the level of amplification, the electronic and environmental background noise gets louder and louder, just as the signal of interest does. The parabolic reflector is a noise-free mechanical amplifier. In the most basic terms, using a parabolic reflector is like cupping your hand behind your ear to make a sound louder, only much more effective due to the parabolic curve. So how does it function? A parabola is based upon a geometric curve. Sound pressure waves arriving perpendicular to the parabolic curve are reflected back to the focal point. The distance traveled by sound pressure passing through any point of the plane of the parabola's rim and then reflecting off the inside surface to the focal point is the same distance. The geometric curve directs the sound energy to the parabola's focal point, and that, in combination with the parabola's surface area, thereby amplifies the signal. In contrast, sound pressure waves arriving off-axis at the parabola reflect off of the dish but are not reflected back to the focal point and therefore are not amplified. Using a parabola requires precise aiming. Wherever you point that parabola with its narrow angle of acceptance, that's what's going to be tremendously amplified. While an animal is vocalizing by methodically moving the parabola across the horizontal axis, listening for the point at which the animal sounds the loudest, and then doing the same with the vertical axis, you can quickly and efficiently locate a sound source that you're unable to see. For field recording, a parabolic curve with a focal point at or close to the rim of the dish is desirable. It provides protection against wind and is easier to carry in the field than a reflector with a focal point outside the rim. You need one more thing to properly aim the parabola. You need a good pair of headphones that allows you to hear that dramatic increase in the loudness of the signal and the great detail that you're going to hear when you're aimed directly at the subject. So what are the cons of using a parabolic reflector? One is that the diameter of the dish determines the lowest frequency you can record. Any sound frequency wavelength that's longer than the dish is wide won't be reflected off the dish, and therefore there's no amplification at those frequencies. The second is that the diameter of the dish makes it a little awkward to carry through dense undergrowth. Another con is that the parabola accentuates higher frequencies and therefore alters the sound that you're recording. So what are the positive aspects of using a parabola? One is it gives you tremendous reach. If you're trying to record a bird that's up in a tree, using a parabola is going to give you a sound that it appears the bird's sitting right on your shoulder vocalizing. Another is that a parabola will allow you to achieve a high signal-to-noise ratio. Its amplification property helps you overcome noisy situations where there may be a lot of other acoustic activity in the area. Because of its great directionality and amplification property, it lifts that sound out of the soundscape for you. In short, using a parabola is going to give you a better signal-to-noise ratio in any given situation and allow you to operate at a greater distance from an animal than you would be with any other type of microphone.
So we have, in addition to the parabolic microphone, we have something called as a shotgun microphone. And all these videos are there in the website, Cornell Labs website. Since we are running out of time, maybe I think I will not play the other videos. I have another video on how to record wildlife basics.
Recording wildlife is something.
There is also another video on how to use a shotgun microphone. Maybe we can see
Perhaps
this.
you've been recording with a smartphone or a handheld recorder for some time now, and you'd like to up your game. One of the best things you can do to improve the front end of your system is to attach a directional microphone. For wildlife recording, two types of directional mics are commonly used: the Parabolic Reflector system, or Parabola for short, and the shotgun microphone. In this session, we'll focus on the shotgun microphone. Specifically, we'll talk about four things: why use a shotgun mic, how it functions, how one aims a shotgun mic, and the pros and cons of why you'd use a shotgun over, say, a parabolic reflector. A shotgun microphone is one of the most commonly used mics for recording bird and other wildlife sounds. It's a directional microphone, a characteristic that helps reduce the impact of unwanted sounds in your recording, and it's relatively inexpensive. So how does it function? What gives a shotgun microphone its directional property is the interference tube, a hollow tube with precisely placed slits. Sound pressure waves arriving directly at the front of the tube pass, unimpeded, to the microphone's diaphragm. However, sound pressure waves arriving off-axis are delayed in their arrival at the microphone's diaphragm. When we look at the microphone's polar pattern, an illustration that roughly shows how the microphone picks up sound, we can see the angle of acceptance and the angle of rejection. This is where the mic will be most effective and least effective for picking up sound. At low frequencies, it becomes ineffective and significantly less directional. So how do you aim a shotgun microphone? Aiming a shotgun is intuitive. Point the interference tube in the direction of the target sound, making sure to orient it both horizontally and vertically. Wherever you illuminate with that conical beam, that is what the shotgun is most effectively picking up. However, not only does the shotgun accept sound in the forward plane, but to the rear as well. Therefore, when aiming a shotgun, the sides of the microphone should be toward the unwanted or interfering sounds. An important addition to your shotgun microphone setup is a windscreen. The purpose of a windscreen is to prevent gusts of wind from directly impacting the diaphragm of the microphone. On a windy day, your audio could sound something like this without a windscreen, like this with an inexpensive foam windscreen, and like this with a blimp or thick fur windscreen. It's best not to have the microphone perpendicular to the wind, but rather to face it head on or have your back to the wind. There are many pros in favor of using a shotgun microphone. For one, its directional property allows you to overcome the impact of unwanted sounds such as other birds or anthropogenic sound. It's straightforward to aim, carry in the field, and to transport. And it's also very easy to track a moving subject. Lastly, the shotgun microphone offers a flatter frequency response than that of a parabola. This is because the shotgun does not differentially amplify higher frequencies the way a parabola does. So what are the cons of using a shotgun microphone? One, it doesn't amplify sounds. Two, it offers no directionality when you're recording lower frequency sounds. In short, a shotgun is a great way to begin building your recording kit. It can help you overcome unwanted sound in the environment and maximize the signal of interest.
Okay, now we
It's
saw
10
the types of microphones for recording the bird calls. Now, always a human does not have to do the call recording. So now there are devices that will do that for you. So you just fix the devices. Like you can see, this is called as the audio moth. It is very inexpensive, and you can buy it like in plenty, and fix it in a forest. And this will record calls for non-stop as per your requirement. So you can set up the call to record in the morning 2 hours, afternoon 2 hours, night 2 hours, and like that. And it will also can attach to another device. It can transmit all the data to your computer through a microphone, through mobile internet, and all such stuff. So there are various types of passive acoustic data recording devices available. One is AudioMoth. Another is this is called as a Swift. You can see on the right side. It's manufactured by the Cornell Lab of Ornithology. So these are all used by ecologists to study the acoustics of wildlife in a forest or in a certain area where they have to study. So they will fix these devices and leave it for an extended period of time, to 3 months or 6 months or 1 year, and then they periodically remove all these calls and they analyze it using some kind of a computer software. So see, this is evolving. Actually, the sound recording is evolving now. You don't have to really go and do all this by yourself. So tomorrow there is no need for any human beings to go inside any forest. They just fix up these devices and it will record on its own, and you can just download all the data, and then some computer engineer will actually analyze all these calls. This is the trend. Okay, this is generally, you can see how a recordist is working on the field. So he takes out a dish and he has a recorder and he has got a binocular. So this is how it happens. And this is another photograph of a recordist who is actually recording a bird call in a field. Okay, now we have done with listening, we are done with recording, and now all the calls are there in our storage device that you are putting on your computer, and now it's time to analyze these data. We will come to this video after a little while. Yeah, so this analysis of sounds, bird calls, it is a science or art. Actually, this began as an art. Later it got converted into science because scientists were interested in getting these calls. So it's both an art and a science. Recording bird vocalizations or wildlife vocalization, nature vocalizations, calls are all, is both an art and a science. Yeah, these two people are the pioneers in as far as the use of acoustics, use of sounds for ecology. This gentleman on the left is called as Murray Schafer. He is a Canadian composer, artist, and the other guy who is on the right side is Bernie Krause, who is a very famous sound recordist. So he started his career as a musician, and he has worked in many albums in the Hollywood. But then later he decided he was going to only record calls of nature, and then he wrote many books. And some of his books are this. He has written a book on wild soundscapes, and another is a great animal orchestra. All of these are available in the internet. You can just, and they come with a lot of sound files also, which he has recorded. So you can put your headphones and listen to it. But most fascinating is how the process of recording and the philosophy behind recording and the recording calls nature sound as an art. You can get a sense of all of these from these books. Yeah, what Bernie Krause discovered in particular field in a forest in California was that each animal has got its own niche in an acoustic spectrum. So if you take a forest, there are many animals. There are reptiles, there are insects, there are birds, and all of them are making calls. And the most fascinating thing that he discovered is each creature, each organism has its own acoustic niche. So they don't overlap. So here you can see on the right side, on the left side, you can see the frequency line, and the bottom line, the horizontal line, is the time and pressure. It also shows the pressure line. So the more yellowish color indicates the more pressure, the more pitch of the call. So here he says, see, the insects are in the top right corner in the 4000 top band, and there is marmot is a mammal. It's a small mammal, and insects, and there are birds. There is an unknown aircraft in the bottom. There are birds here on the middle. So each organism has its own acoustic level. So taken in unison in a big forest, all the sounds have got some kind of a meaning. So what he did was he recorded the entire soundscape And these two guys are the pioneers, and they created a word called soundscape and soundscape ecology. And what they did, Bernie Krause went to the forest and recorded the calls for about many hours, say in the year 1980 or so. Then he went back in 1990, 10 years afterwards, to the same forest, same patch of land, and he recorded the call for, say, a number of hours. And then he compared these two recordings. And there he found a lot of fascinating things. He found out that in between, what has happened is they have leveled the forest, they have cut the trees, and then they have regrown the trees. And what he found out was, once the ancient forest was cut, and most of the creatures vanished forever. Like insects vanished forever, the reptiles vanished forever, and the very few birds came back. So the restoration process was not happening. So this is what he discovered through this soundscape ecology, to recording soundscapes. Now coming to the software, what are the software available for analyzing these calls? So these are all, some are paid and some are free. On the left side you can see software called Osen Audio, which is in yellow, and the middle one is an Adobe Audition, and third is an Isotope. These two are the middle, and the on the right software, they are all paid. They are not free. But Osen Audio is a very commonly available software that anybody can use. You start recording in your mobile phones, you can put it on your computer, uses Osen Audio, you can actually process that. We can have a separate session on how to process and editing the sound files later if somebody is interested. But right now, this scope of this, we will not go into in detail about how to edit the files. Okay, now coming back to the same calls which we listen. Let us see how will we actually visualize this calls of the birds in a software. Okay, this is the recording that you heard. Okay, so now when you are putting it in a computer and you are looking at it in a screen, this is how it will look. This is called as a spectrogram or a sonogram. There are different names for this, but this is how it looks. So you can see on the right side, on the horizontal line is the time, and the vertical line is the frequency. So when a bird vocalizes, each bird has its own frequency, each bird is its own pattern, and somebody is looking at the visual, the sonogram, will be able to identify that it is a large-billed crow. And if you want to see this on another website, I can just show you how it actually happens live. Okay, so this is how. Yeah. So you can train yourself into interpreting these calls visually on a XY axis, and through a sonogram you can identify there are many birds in this call. See, not the crow call is the most prominent, but in the background you can hear a lot of other bird calling. Even that you can identify. There is a tailor bird and some other birds will be there. So to a trained person, if you look at the spectrogram, you don't have to listen to it. You can just see the visual, the graph, the spectrogram, and then say that, okay, there are so many birds are there. And the computer engineer who was writing the software actually writes the software so that it will be able to identify all the birds in this particular graph. So we will not go into all the birds because we have not much of time. So I have just put, okay, this is a house crow. You have heard the call, we will not hear it again. Okay, and this is how it looks. The spectrogram, as when you pull the calls into a computer and then use a software, a visual editor like this, Osen Audio, or Adobe Audition, or Isotope, you can see the picture as a new screen. This is how it looks. Over a period of time, if you look at the picture, you will say, okay, this is a house crow, this is a large-billed crow, this is a tailored bird. So that is how you train yourself over a period of time. Yeah. So maybe we can look at this also on a side. This is actually a very nice call recorded by my friend. See, you can see many patterns on this. So all these lines that goes ups and down, there are actually names for that. We can go into it detail once we go into an advanced session. But right now you need to be familiar with all these concepts. So I'm just introducing all these concepts to you so that tomorrow when you come back to another session, so it will not be something foreign to you. This is a common myna. It is not some taiga flycatcher or some yellow rumped wobbler. This is it is found everywhere commonly. So I would recommend everybody to actually pay attention to these common birds that are around you so that you can get familiar with the various vocalizations, the variations of the call, and try to understand. You will be very puzzled. You will not have any answers. But that is the way to start. That is the way to start into getting into this kind of bird call recording. Okay, here it is. Yeah, this is how the spectrogram of a Taylor bird looks. See, this is not found in the common urban areas. This is just found, this is a Tamil, they call it as Kaudari, but in English it is called as grey francolin, and its call is rather distinct. And the spectrogram looks like this. So you can see how frequently it calls, and it travels from a low frequency to a literally, I think 30k, like so. Okay, fine. Now this is how you actually upload the data into eBird, and then you see the sonogram. There are various websites. There is a website called Zenocanto. There is a website called eBird, and a lot of software available to analyze all these. So once you start recording, then you will get into this kind of thing. Now the thing is, all this is now moving towards the more advanced computers are taking over. So it is powered by artificial intelligence. Now this is the future of all these things. So the bird call recordings are being now, all the pattern recognition is being happening through machine language to artificial intelligence. There are people who develop software which will try to identify, may look for patterns in the recordings, and the humans, the little bit, the interference of humans, intervention of humans is coming little by little, it's reducing. So there is a website called as a BirdNet. So you can just go and check the Google and say birdnet.cornell.edu. So there you can upload a file. Whatever recording, you can upload the file, and there it will give you whatever bird it is. Right now they have activated it only for the North American birds, but they're working on the birds of India, and soon you will be able to upload all your calls, and the software will tell you what bird it is to a reasonable probability. It also makes error because you have to train the software first, and only then it will be able to give you the correct response. But right now this is just a beta stage, but it is fully functional for North America, but not yet for Asia or India, because it's a very difficult process, because you need so many different calls of the same bird, and only then the software will be able, you can train the software. So the future, we are talking only about the future of the bird call recording of the soundscape ecology, where the machines are going to take over, the computers are going to take over, and slowly the science is taking over, and the art aspect of it will be slowly diminishing. Okay, how does it work? So you find here is a microphone which will pick up all the data, and then and it creates these spectrograms which I told you, and there is a software which is called algorithm, and then it gives out the species probability. So in case there are 3 species shown here, it says this species probability is 91%, and second is 14 and 9%. Then what happens is it goes into the archive of the database, and then finally it gives a prediction saying that this is a bird to reasonable accuracy. It may be wrong. See, when it was introduced first in North America, it was frequently giving out wrong information. But as many recordings were coming inside the database, then it also its probability went up, and it's was making less and less of errors. Okay, now they are launched it. This kind of thing is happening in India also. They have launched it in India, and there are people who are recordists who are contributed many recordings to the eBird and Macaulay library, have been actually roped in to annotate their recordings. Like, for example, you can see this spectrogram, and somebody will be sitting in front of a computer screen and doing all this, saying that okay, this is an American redstart, this is a black-throated blue warbler, American robin. All that they will mark. They will make a small square and then post the file into the computer. The software program will take it, and then it will create a pattern recognition system, so that tomorrow when they launch it in India, the Merlin app will be able to identify even all the birds that you are listening to. So you don't have to really work very hard for that. Okay, we have come to the end of this session, when I thought that okay, let us remember the father of Indian ornithology, and his famous work was the birds of the Indian subcontinent, Pakistan, where he has actually written a lot of notes on the vocalization of the birds. I am actually posing this as a quiz for all the participants today. You can just go through these 3 reports, what do you call, observation of Salim Ali, and then you may be able to come up with the name of the birds. This is a quiz for all of you. This is sort of an anticlimax because we have seen very erudite discussion on all the technology and other things. But then Salim Ali has already written about all these bird calls in his book, and you should read all his books, his observations on all the birds, how it vocalizes, and maybe you will get an idea of how you can actually approach the bird sounds. So this is actually a quiz. Now I will read out the first one. So the first one says, a single unmistakable raucous walk or quirk is uttered from time to time while fighting to and from the feeding grounds, partially fled chicks in the nest, and when out clambering among the adjacent branches, keeping incessant clamor, click, click, click for the being fed. Okay, it may be difficult for everybody, but second one is very easy, and third one is, of course, there is a clue, inbuilt clue in that. So I believe, so thank you very much. I think we have come to the end of the session, and we will take up the quiz if you have any other questions.
So thank you, Subbu. That was absolutely wonderful. There's one question in the spectrograph vertical axis. Is it amplitude or frequency?
Frequency. It is frequency.
It's frequency. Yeah, I thought as much. It was there in that. All right, and I do not see any more questions. Third one is Supo. Okay, there are some questions coming. I'll just give it a minute. And a lot of accolades for you, Subbu. There's one question. Is there any way we can minimize background noise using a free smartphone app?
No, in the beginning, I started recording the call. I wanted to eliminate all the background calls, but actually what they advise is not to eliminate any calls. Like, you have to record it with all the background noise. So no point in actually trying to hide the noise, because in the process you will actually lose out a lot of information on the bird itself.
Okay. All right, I hope that answered your question, Vidya. Yeah.
Yes, sir.
And yeah, of course, this is a very fascinating thing, you know. going out into the field, listening, recording, and then coming back and interpreting, being able to distinguish all the. So what do you normally do? How do you, let's say there are about 8-10 calls in one recording, Subbu. So do you actually go and isolate all 8-10 calls and, create a spectrograph for all separately, or?
It depends on what your purpose is. Sometimes we want calls of a particular species, then we
Okay.
take out a parabolic phone, we go near the bird and record it
Okay.
and try to isolate the call.
Okay.
Otherwise, like if you want to record soundscapes, like you have a different setting and then you try to record all the calls that come inside your
Okay.
microphone.
So because for a bird like the common myna, for instance, its vocalizations are varying. I mean, if you really listen to the myna,
Correct.
in a period of 5-6 minutes, there's so many calls, and there's so many imitations of so many other, birds. Yeah. It's and so's your drongo.
Correct.
Yeah. So,
So the first, let me come to nobody is I think answering the quiz.
okay.
So the first one Salim Ali has described is a black crowned night heron,
Ah.
which is commonly available everywhere. Even in the city, it is roosting.
Yeah, a lot of them are.
And the second one is a little grebe. So he says, in addition to runs of shrill, rather musical trilling, a sharp monosyllabic click is uttered repeatedly when agitated, as on approach of nest by intruder, and also sharp squeaks like an unoiled bicycle wheel. So third one is, of course, is a hoopoe. So all these vocalizations, he has not used any special technology like we are using now. So he has just observed with his binoculars and listened to it and came up with some description like this. I think each of us, we are capable of doing something like that. So we don't have to really rely on technology for all this. So at the end of which, I think it is like slightly an anticlimax that we are actually bringing in Salim Ali into all this.
No, not really. I mean, he really used the two things, equipments given on either side of our head. And like you rightly pointed out, he listened more than heard. And so that's what helped him. Anyway, thank you very much,
Thank
Subbu.
you very much, Subbu. It was fantastic. It was an enlightening talk. And the way you had structured it also, you went from the basics, right from the hearing to the physics of the sounds and how to interpret. It was really wonderful. Thank you very much.
Yeah.
And actually, I was recalling you were talking about shotgun microphone. I mean, my knowledge about this is limited, but Ben King, when he came in the 1980s to Chennai, he wanted to record. I think you might know. I am speaking for the others' benefit. He wanted to record the call for the yellow-throated bulbul. Which
He
was
went with
Shantaram.
Shantaram.
Yes. So I was along with him. I had run with Koneri Rao, Santaram, and Ben King. So he had brought that. That was a new thing done in the 1980, a shotgun microphone with. He used to record it with Sony Walkman Pro. I mean, that was a cassette recorder. So I think that was the most expensive. So he recorded it and it came out brilliantly. Actually, he gave one or two recordings to us also. If I will find out whether I can locate it. That's number one. Number two is our member Tyagarajan. In the 1980s, he got a small parabolic reflector from abroad, and he recorded calls in and around Bangalore, in Kanakapura and all that. It came out quite nicely. But I think after that he lost interest and I don't think he is recording anymore.
He's still having that parabola. That's what he told me.
He still has that parabola.
He still has
okay. See, my brother and Tyagarajan, they started discussing and then they wanted to make one and all that. So I think he still has that parabola. Okay. That's good. Anyway, thank you very much, Subbu. Lovely.
There's another question that has come. Is there a reference or book where calls, voice, songs, say for a particular bird like tailor bird can be studied for identification?
No, I don't think there are any books which actually gives all the calls and voice. There used to be a website in Malaysia, but I think they have shut down the website. that is only for bird behavior, and it used to contain so many posts by the members. But now I think it is now defunct and it is no more working.
Yeah, but a very deep reading of the writings of Dr. Salim Ali will give you a very good
definitely,
idea.
definitely it will give you a good,
Very good idea.
very good idea of on.
So, are there any more questions? Let me just check.
Subbu, can I ask a question?
Yeah.
Yes, sir.
Just wondering as to the remarks that you came across when you are out in the field recording bird calls. As it is with the binoculars and the camera, you get all sorts of questions. Why are we come here and whatnot? Any experiences with the shotgun microphone or the parabolic reflector?
No, I carry it everywhere, sir. I put it on overhead bin while traveling on a flight.
Okay.
And I put the gear in my luggage. So I have not faced any problem so far.
No, not in the travel, out in the field.
Yeah, people will come and watch you, but what can we do about it? So you are less like a curious person with so many gadgets on top of you.
Thank you.
Sir, you are having a shotgun microphone, so maybe you can.
Yet to start using it, bought about 2 to 3 years back, still not yet started. So I hope to do it. We'll call you later for some advice. Thank you.
So if somebody is interested, they can write to me. I think I have shared my contact, so they can join me. I have the latest gadgets. Whenever I go out, I just record calls whenever possible. So if somebody wants any tips on recording, they can just contact me.
Yeah, okay. Then thank you very much again, Subbu. That was a great morning that we had now. And like Subbu said, if any of you are interested, you can always get in touch with him directly. He is also on our MNS WhatsApp group, so you can always reach out to him. And thank you all very much for being here this morning. And I wish you all a very nice Sunday and enjoy the rest of the day. See you again next month, if not earlier. Thank you all.